Hey, thanks for coming to learn about turning on the lathe. We've got about 5 things we're going to cover in this video. First is touching off the side of a part, then the cleanup cut. These are things you heard about when we did facing, but we're going to look at it in the turning operation here. How important it is to measure the diameter of that after the cleanup cut and in subsequent cuts. The fact that we can take cuts up to 50 thousandths of an inch per pass. The importance of remeasuring again with a caliper. And we'll look at turning safety review. Let's start with touching off the side of a part for a turning operation. We've touched off the part, we've zeroed at. Do you want to go do a turning operation now?
Now we'll set up and we'll do a turning operation. We basically have got the tool set up properly for doing a turning operation. So what I'll do is I'll touch off the outside diameter and I'll set my zero, and then I'll be able to measure the part and create a bunch of diameters for you.
Okay, so let's just review. Turning is what we did previously where we brought the, or facing. Facing was what we did previously. Don moved the cutting tool inward and made that nice smooth surface. Now, Don, that is a perfectly perpendicular surface to the longitudinal direction.
Yes, it's perpendicular to the center line of that part right now.
Okay. All right, now the next thing is this. Let's say we're going to set this diameter. Right now it's a little bit over an inch. What are you going to take that down to?
Well, we can take it down to 7/8 for starts, and then I can take another diameter down to 3/4, just so you can see how the value of a DRO is.
Okay. How far are you going to go in? Are you good?
We can go in an inch, inch and a half.
All right, so inch and a half. I mean, now you're saying, do I have an inch and a half? This is where having this is handy, right, Don? You don't have to get the caliper out and do all that stuff. I just lay this in here and I see, oh, we've got about 2 inches sticking out, okay? So that inch and a half is okay. How close can we get to the collet before we need to be concerned?
Don't hit the collet.
Okay. All right, hit the collet. Don, these...
Leave yourself clearance. So if I need my part to be 2 inches long and I need a cut-off operation, then I need to pull my part out a little more.
Okay. All right. The collets are expensive. The collet closure is even more expensive. You remember I talked about the madman with the red face coming at you if you did something wrong? Messing up a collet and collet closure will probably get that man to come towards you.
Yes,
right?
Indeed.
Okay. All right.
Fire in his eyes.
So, Don, we are going to go 1.5 inches inward at 7/8 inch. 7/8 inch diameter. Okay, show me what we need to do.
Right. I'm going to start you off. I'll turn the spindle on. I'll set my outside diameter, and if you guys just follow along, we'll narrate as we go.
Okay. So probably what Don's first going to do is he's going to move that cutting tool inward, and he's going to touch off. You're going to see just as soon as he starts making chips, that's called touching off.
As you can see, I just touched off. I see the material starting to turn silvery or brighter silvery color. All right, I can go up here and I can zero my y-axis. That's my cross feed. All right, now I can look at that. I have a habit. I like to zero down here as well. Some guys don't. That's the outside diameter.
Let's review the idea of touching off. And touching off is really just to give you a rough idea where the side of the part is located and to input that into the DRO. First is you're going to move the tool so that it moves slowly in the crossfeed direction until it touches the side of the part. Okay, this would be the cylindrical or round side of the part. So just as soon as some chips or some shininess appears on the part, you've now moved to the touch off position. You can then zero the Y by pressing the Y0 button on the DRO. And remember, the Y direction is the axis that's perpendicular to the axis of rotation. Okay, so Y would be changed by turning the cross feed. Now once you have that 0 set in the DRO, you're ready to start making a cleanup cut. Now before you do that, you want to move the tool in the positive X direction, in other words away from the spindle, so that we can move it to a different diameter position. So moving in the positive Y direction just to make sure the tool is not going to be hitting into the part when we change Y. Alright, let's look at what a cleanup cut looks like and what we do from there.
I'm going to turn this up about 15 thousandths extra, bring this to 0. I'm about 15 thousandths. So now two things I did by doing that is I verified that the dial on my cross slide is pretty much the same as my digital readout. I got 15 thousandths here, 14.8. That's pretty close. I'm going to re-zero here.
All right, wait a minute. I thought we zeroed when we touched off. Oh, then you messed around here?
Yes. I want to take a little deeper cut. I want to establish my tool 0. I'm creating a reference for my tool so I know.
All right, so it's at 0 now. So if I move this down, I shouldn't be taking hardly anything off.
I'm going to take 15 thousandths off.
You're taking 15 thousandths off right now.
Yep.
Oh, okay.
So I can use this where I can use my scale.
Be very careful. Be very careful.
Right? So I'm not watching the digital readout. I can just be very careful. Watch this like this. I can look up here to my digital readout.
All right, he did that. He turned. Wait a minute. So you turned off the power feed.
Yep.
All right.
I turned off the power feed at about 1:400.
Okay.
All right.
All right. Now, let's. You're going to turn this off, or you're going to just move the part away. All right. Now, in that operation, Don, I got a little bit confused because you touched off, you zeroed the Y, all right? Then you used a cross slide and you went in minus 0.15, and then you hit 0 again.
Right. My stock is starting out at roughly a 1 inch 003, 004. So I know I got room to play to get to 1 inch 875. So I want to take a nice cleanup pass so I know what the tool is actually machining size-wise.
So we wanted this to go down to, what, 7/8 of an inch?
Eventually.
7/8 is what? 0.875. So it was an inch. He took off 0.15. We're down to
1 inch 90, or we're down to 990.
990.
So
990.
Because we're dealing with a radius or a diameter, I can actually tell this DRO what diameter I've just turned. All right. Otherwise, if I keep zeroing each time, if I'm at 990, I'd have to do the math. 875 minus 990 minus 875, and that's how much material I would have left. All right. I can let the machine do all the thinking for me.
Okay.
All right.
I think I see where this is going. Don, you just did this small cut off there just so you have a nice, true cylindrical surface.
Correct.
You then measured it with your caliper. You found it was 0.990.
Correct.
All right. So now what are you going to do?
I'm going to input that number into the DRO. So in other words, I'm telling the machine that I'm qualifying this tool. I'm telling it what size diameter this tool will be turning at any given time.
Okay.
So I say I push the Y. I get an enter dimension up here, and I'm going to put in 0.990. And as you can see, I entered this over here as Y. I hit the ENT, enter button, and now it says 990. So
let's review the idea behind a cleanup cut and what it's used for. First of all, while the cutter is out in front of the part, I would say what I mean by that, further away from the spindle than the part, you can use the cross slide to move your DRO into a position that's 15 thousandths of an inch inward, okay, toward the part. Remember, we've touched off and made Y equal to 0, the current outside surface of the part. We want to move in about 15 thousandths from that, and we're going to do what's known as a cleanup cut by engaging the longitudinal power feed. This is done by taking the power engage handle, pushing it in, and going up. Remember in the last movie when we did facing, we pushed it in and then went down. But for longitudinal feed, and when it's in the forward direction, a longitudinal feed is going to move the cutter in toward the spindle. So we're going to take off 15 thousandths of an inch off this part. While this is cutting, you should put some drops of coolant oil in to reduce heat. And you want to make sure you stop the power feed and disengage it by pulling it downward and inward into its neutral position about 1/10 of an inch before the end. Now in this case we wanted to get to a length of 1.5 inches, which when you're going toward the spindle is in the negative direction. So we had faced off the end in a previous movie and called that 0. So 1.5 inches toward the spindle would be a coordinate of minus 1.5. So at about minus 1.4 you disengage the feed and you use the hand feed to move it in slowly the last 1/10 of an inch until you get to exactly 0.1500. You can then back the tool away from the part, both in the positive Y direction to move it toward the operator more away, and then you can use the X to crank it away from the part and away from the spindle. You can then turn off your spindle, okay, after you're done with the cleanup cut. And what the cleanup cut does is it produces a perfectly cylindrical surface. So when you take a piece of stock just off the rack, it may not be perfectly cylindrical, and therefore taking diameter measurements may not be completely accurate. But after you do an operation, a cleanup cut on the lathe, you are now going to get a geometrically nearly perfect surface. Obviously there is nothing actually that's ever absolutely perfect, but this is as good as we are going to get. All right, now along with that, we want to measure the diameter after the cleanup. So you obviously we talked about you turn off the spindle, you move your tool away. You don't want to be in close proximity to the sharp cutting tool anytime your hands are there. You make the measurement of the diameter with your caliper, and then what we're going to do is we're going to set the Y value on the DRO to that measured diameter. And then from then on out, the Y value on the DRO is always going to show the actual diameter of the part. So to set this Y, you press Y on the DRO. Then you're going to see a prompt on the display. It's going to say ENT dim, means enter dimension, I'm sorry. And you're going to then type in with the keypad your measured diameter. You're then going to press the ENT button, and that's going to register that diameter at that cutting position. Okay, now we're going to talk about taking some subsequent cuts. All right, our goal eventually is 0.875. So we're just taking a little bit off, and now Don turns on the machine, and he's going to push the crank in and up so the power feed is moving us inward. Okay, and he's stopped. Don, what's the matter?
Nothing's the matter. I just need enough to make a measurement.
Oh, okay.
I got a lot more room to go, so I don't want to waste time with just a little bit.
Okay. All right. So Don just did a little bit. He wants to see, the DRO says that we should have a diameter of 0.949.
I'm getting 952.
He gets 952. So
that's a good thing. It's cutting big.
Okay, it's cutting big.
Some things could have happened. I could have bumped this, could have got some backlash.
Okay.
So I'm going to go down to 900 and see what happens.
All right. So Don's going to go down to 900. And then he's going to do another measurement. All right. So he put this lever upward. He's putting some coolant on there. I see smoke.
We're sending signals.
All right, sending signals, Don says. Chips are flying. That's why we have safety glasses on. He's watching this. As soon as he gets to 150, he wants off. All right, and he hand feeds it the last little bit. Was that right, Don?
Yes.
All right. So when you get close to that being what you want, you're going to want to disengage the power feed and then just crank it in slowly the rest of the way. All right, he's going to put a diameter on that. It's supposed to be 900.
All right.
He's getting
I'm at 896.
896 done. So 896, and you're supposed to be at, and it's at 899.
So before I got plus, now I got minus, so I can't really trust this 100%. Okay.
All right, so folks, I think what Don's telling me is that the DRO is a guide. It's close, but what you always need to trust ultimately is your measuring instrument.
That is correct.
Okay, and remember, we're not ever trying to measure something while it's turning. All right, so right now, Don, we were at 0.896. That DRO says 8. We want to get it to 850, but remember, we want to be measuring well before that. Now, Don says about 50 thousandths or 0.05.
And then I'm bringing it up to 8. 78. That's my extra 3 thousandths.
All right, so let's go to it.
No.
He's measuring it.
We're right at 875 and maybe 5/10 more, slightly large.
Here's one of the things to remember. You can once you get close, you can take little bits off and measure, a little bit off, measure. One thing you can't ever do is put more material back. All right, so you don't want to err on taking too much off. Right. Okay, so Don, we've turned this down to 0.875, 1.5 inches. All right, so we've done a turning and we've done a facing operation. Right. Is that good?
That's good.
Let's review the idea of what needs to be done on each subsequent cut or subsequent pass to bring a diameter down to the correct value. Don mentioned that the biggest amount you should take off per pass is about 0.05, which is 50 thousandths of an inch. Okay, so any more than that is getting too aggressive for entering 153. You should put drops of coolant oil to reduce heat. You should always stop the power feed at least 1/10 of an inch before the end, and then use the hand crank for the last 0.1 inch. And this is the same thing we did for the cleanup cut. Remember, you want to back the tool away from the part, turn off the spindle, and measure as needed. Now keep in mind that as you get closer to the desired diameter, the amount you want to take off is going to be less. As you get really close, remember, you can never put more material back on the part. You can only take off. So it's always best to be conservative, measure, and adjust. So making lots of measurements is the best way to hold a real nice tolerance. Let's look at some safety things that we've talked about before and maybe for the first time in this video. Once again, never touch any moving parts on the lathe, neither your part, the spindle, or the feed screw. You never want to make a measurement with the spindle on. You must turn the spindle off. Likewise, you should and must move your tool away before making a measurement. You don't want to run your hand while taking a measurement across a cutting tool and end up with a bunch of blood all over yourself and the part. Use that chip brush when necessary. You're going to see longer chips being formed a lot of times in turning operations. Don't succumb to the temptation of maybe I'll just grab this one with my hand. Never do that. Never, never. And keep in mind, what you're wearing at a lathe can be the determining factor whether you walk away from that lathe safely or have a very egregious and terribly permanent injury. Nothing that dangles, nothing that can get caught in any turning parts. You know, so we've talked about no hoodies, no necklaces, jewelry, long sleeves, hoodies. Okay, please do not wear those things near a lathe. I think you're ready for the turning questions. Number 1, compare a facing operation with a turning operation. Number 2, why must the longitudinal power feed be disengaged at least 0.100 inches from the desired end of a cut. 3. List the steps for setting the Y value on the DRO to the actual part diameter. 4. What is the maximum amount of material that may be removed in each pass of a turning operation? That would be for our Engineering 153 setting discussed here. What should be added to the part to reduce heat while you're making a cut? And then our last question, number 5. Why must the part diameter be measured with a caliper multiple times during a turning operation? Hey, thanks for coming. We just have one short video left on the lathe. It's center drilling and drilling. It's kind of interesting, so you'll want to see it. And I can't wait to have you back.